Namaste to all of you. Present, we are doing the binomial theorem. In the binomial theorem, basic part already I given. In the last class, I revised the topic also. Okay. In the last class, this is the last bit. If the coefficient of x power 11, coefficient of x power 12 are equal, then what is the value of n? We did it. So we take in general term, we simplified. After that, we got n is equals to 20. I hope that video is clear for you. Just one time you can practice. Okay. You can understand. Next. Now listen here. One more example here they given. So here one example is given. Listen. Using binomial theorem. Using binomial theorem. Prove that 5 power 4n plus 52n minus 1 is divisible by 676 for all positive integers n, for all positive integers n. This is the bit they given. Okay. Listen all of you. So prove that with the help of binomial theorem. So using the binomial theorem, prove that 5 power 4n plus 52n minus 1 is divisible by 676 for all positive integers n. Listen. So first of all, what is they given? 5 power 4n plus 52n minus 1. This is the value they given. So this value I can write 5 square whole power 2n plus 52n minus 1. Got it now? A power m whole power n. A power m whole power n. What is the formula? A power mn. So basing on this formula, 5 power 4n I can write like this. 5 square whole power 2n. So 5 square whole power 2n means again 5 power 4n. Then again 5 square. How I can write 5 square value as 25 whole power 2n plus 52n minus 1. Then this 25 value I can write as 26 minus 1 whole power 2n plus 52n minus 1 I can write. Then this is in the form of, okay, 26 minus 1 whole power 2n. For any positive value, what is this 2n value? Even number only you will get now. 2n is always even when it is positive integer. So this value I can write as 1 minus 26 whole power 2n. I can write like this. Plus 52n minus 1. Now expand this value with the help of binomial theorem. If I expand binomial theorem, what I can get first value? 2n cn naught into 1 power 2n means 1 only. Plus 2n c1 into 1 power 2n minus 1 into minus 26. Plus 2n c2 into 1 power some value leave it. Minus 26 whole square you will get. Plus 2n c3 minus 26 whole cube. Plus 1 last value 2n c2n minus 26 whole power 2n is the value. Plus 52n minus 1. Got it, mom? With the help of binomial theorem, I expand this total value. And here don't confuse that here. Here I taken 26 minus 1. Here 1 minus 26. Anyway, power 2n is there now. Power 2n means even only, you can interchange. If it is odd power, you can't change. But even power, now you can change it. 2n c naught. What is value 2n c naught value? Already I given n c naught value is equals to 1. So this value 1 plus this is nc1. What is nc1 value I given? nc1 is equal to n. But of course in place of n, 2n is there. So here I can get 2n into minus 26 plus next value 2nc2 into 26 square plus 1 plus last value. This is the value 2nc2n 26 whole power 2n plus 52n minus 1. Minus 1 plus 1 cancel. 2 into minus 26 minus 52n plus 52n cancel. Now listen. In the rest of all the terms, here 26 square you will get. Next value minus 26 cube you will get. Like that here 26 whole power 2n. That means 26 square is common in every term. I can common that value. That implies if I common 26 square, what is the rest of the value I can get? 2nc2 minus 2nc3 into 26 plus 2nc4 26 square minus so on, like this you will get. So here 26 square means what is the value? 26 square means nothing but 676. So 676 into some integral value. So 676 into some integral value means what I can conclude, ma'am? Therefore, the whole value, the given whole value, you can written as 676 into some integral value. What is that meaning? The whole value is divisible by 676. And in order to show that divisible by 676, here what is the formula we are using? Binomial theorem we are using. And hence the proof. That means with the help of the binomial theorem expansion, we proved that 5 power 4n plus 52n minus 1 equal to 676 into some integral value. What is that meaning? The whole value is divisible by 676. What is here n value? N is any positive integral value. I hope that this is clear for you. Okay. Next. So this is also one more kind of examples basing on the binomial theorem. Okay. Next. Here one more example they given. Find the number of terms. Here they given. Find the number of terms with non-zero coefficients in, here the expansion they given as 4x minus 7y whole power 49 plus 4x plus 7y whole power 49. How many terms are there in this expansion? That is the bit they given. Listen, ma'am. First of all, power 49 is there now. Power 49 means how many terms will be there first of all? 50 terms. Here also power 49 is there. So power 49 means even in this expansion also how many terms will be there? 50 terms are there. Got it now? Now can we say 50 plus 50 100? No. Here 4x minus 7y is there, 4x plus 7y is there. With the help of the binomial theorem, if you expand this value, you will get alternately plus to minus terms, you will get it. If you expand this value, you will get only all positive terms only, you will get it. Now in that expansion, how many terms we will get, that they are asking. How many terms we will get it. Listen first of all. If you expand this value, 49 C0, of course instead of every time 49, simply I am using C0. So here C0 means 49 C0. Keep in your mind. So what I can get? C0 into 4x whole power 49 minus C1 into 4x whole power 48 into 7y. Of course here minus 7y. That minus 7y here I am writing directly. Plus C2 into 4x whole power 47 into 7y whole square. Generally here plus, here minus 7y whole square. But minus whole square means plus only, you will get it. Like that if you proceed, what is the last value you will get, mom? Minus 49C49 into 7y whole power 49. Like this you will get the value. Then expand this value also, mom. If you expand this value, what you will get, tell me here? C0 plus C0 4x whole power 49 plus C1 4x whole power 48 into 7y plus, like that, what is the last value? 49C49 7y whole power 49. When you adding these values, all these terms cancel, next to C3 like that cancel. Then what is the remaining terms, tell me? C0 2 times of, which is equal 2 times of C0 into 4x whole power 49 one value plus C1 terms cancel, C2 into 4x whole power 47 into 7y whole square, like that, till where you will get 49 C48 4x into 7y whole power, what is the value will be? 48. Like this you will get the value. Then how many terms, mom? 0, C0 one value, C2 one value, C4 one value, C6 term one value, like that C48. Till here counted 2 into 1, this is 2 into 2, like the 2 into 24, and this is one more value. So how many terms are remaining? Therefore, number of terms is equals to, number of terms is equals to 25. Got it, mom? So this is one more example basing on the binomial theorem. This expansion they given. This is one more expansion they given. Here plus minus means, mom, alternately in this expansion you will get a plus term, minus term, plus term, minus term, like that. Here 4x is there, 4x. Instead of minus 7y, plus 7y is there. So if you expand, all are the positive terms. Then if you add these two values, you will get 2 times of 49C0 4x whole power 49 plus 49C2, like this you will get. Then how many times you can count it? If you count it like that, C0, C2 up to so on C8 means like this. C0, C2, C4, C6, like that C48 values. Till here how many terms are there? By 2 you will do. Like 2 into 1 for your understanding, I get written like this. 2 into 2, 2 into 3 means third term, like the 2 into 24. So till here 24 and the C0 term, one more term is there now. So total number of terms is equals to 25 you will get. I hope that, mom, this is clear for you. Next example. So these also one more important concept, mom. You can do one thing with the help of this concept, just yourself you can try. One example I will give. x plus a whole power n plus x minus a whole power n. If n is odd, here you can calculate number of terms in this expansion. X plus a whole power n plus x minus a whole power n when n is odd. X plus a whole power n minus x minus a whole power n. N is odd integral value, odd positive integral value. How many terms will be there? X plus a whole power n plus x minus a whole power n. When n is even integral value, how many terms will be there? X plus a whole power n minus x minus a whole power n. N is even, then how many terms are there? Just try yourself. Here n is odd. These are the two cases when n is odd. That too, one value plus, one value minus. How you can cross check? Simple. You can take n is equal to 3 only, you can take it. If you take n is equal to 3 here and here, plus is there, cross check. Just now we completed. We got, if n is odd, we are getting n plus 1 by 2. Just before only we completed that one. Now n is odd, but here minus is there. How many terms you will get? Maybe in this also you will get n plus 1 by 2 only. If n is even means you can take n value as 4. With the plus, how many terms you will get? With the minus, how many terms you will get it? Sometimes JEE mains point of view, directly they will frame the bits basing on this concept. Simple concept. Just if you did yourself, you can understand easily. Take n is equal to 4, n is equal to 3. Cross check. Just you can mention as one point also that one. I hope that this is clear for you. Next. After this one, here one more example is there. Middle term. This is the next concept. Middle term or middle terms. Middle term or middle terms. Listen. What is middle term or middle terms? For example, if you take a plus b whole power n, with the help of binomial expansion, if you did expansion for this one, a plus b whole power n. Here two cases. N is even, one case. N is odd, one more case. N is even, n is odd. In these two cases, my aim is to find middle term. With one simple example, I will tell you. For example, a plus b whole power 5, a plus b whole power 4. Two cases I taken. This is odd integral value and this is even integral value. Then how you can find the middle term or middle terms? Listen, if the power 5 I taken means odd integral value I taken here. What is the number of terms here? In this expansion, the number of terms is given by n plus 1. Anyway, here it is any positive integral value. In the expansion, a plus b whole power n, number of terms is given by n plus 1. So here in this expansion, how many terms I can get? T1, T2, T3, T4, T5, T6. But if you observe in this expansion, here power value 4 I given. So anyway, the number of terms in this expansion is given by 4 plus 1, 5 terms will be there. Means T1, T2, T3, T4, T5 is the value. So whenever n is odd, this is the case. Even number of terms you will get it. Then what are the middle terms? T3, T4. So here one important point is there. In the expansion a plus b whole power n, if n is odd, there exist middle terms. Middle terms I can get. And what are the middle terms also? If you observe here, T n plus 1 by 2, comma, T n plus 3 by 2. These are the middle terms. You can cross check. Here n is odd. Instead of n, 5 is given. What is the value? 5 plus 1 by 2, 3. 5 plus 3 by 2, 8 by 2, 4 is the value. So this is the logic. Second case, for example, n is even. In the expansion a plus b whole power n, if n is even, if n is given directly, strictly we can say this is the middle term. This is the middle term. So only middle term, only one term only exists. One term only exists. And what is the formula here? Of course n is even. In this case, there you will get middle term. Middle term only you will get it. And the middle term is given by T n by 2 plus 1 is the value. Like this. Here T3. How you will get T3? T 2 by 2 plus 1. 4 by 2 plus 1. 4 by 2 means 2. 2 plus 1, 3. Like this. So, here the concept is in the binomial theorem, a plus b whole power n, if n is even, then there exists middle term. And the middle term is given by, this is the formula, T n by 2 plus 1. If n is odd, there exist middle terms. Means two terms we can take as the middle terms. And those middle terms are given by the formula T n plus 1 by 2 comma T n plus 3 by 2. So this is also one more concept you have to remember. Okay. Next, middle term concept, this one. Next, after this one, here all these terms, try to solve this one. And here one example they given. Just try for this example here. If the sum of odd terms and the sum of even terms in the expansion x plus a whole power n or P and Q respectively, then show that first bit P square minus Q square equal to x square minus s square whole power n. Second bit 4pq equals to x plus a whole power 2n minus x minus a whole power 2n. This is the next example. Once again, listen here. According to data, if the sum of odd terms and the sum of even terms in the expansion x plus a whole power n are p and q respectively. So first of all, we will observe what is the expansion for x plus a whole power n. With the help of the binomial theorem, if you expansion, if you did it, x plus a whole power n, tell me what you will get. C naught into x power n plus C1 into x power n minus 1 into a, C2 into x power n minus 2 into a square plus 1 plus last value you can observe Cn into a power n. This is the expansion for x plus a whole power n. Now, sum of odd terms. Odd terms means first term, third term, like this. Sum of odd terms denoted by p. So by data, here I am writing by data, what is the value of p? Sum of odd terms. Sum of odd terms means p value c naught into x power n plus c2 into x power minus 2 into a square plus c4 into x power n minus 4 into a power 4 plus 1, let it be. Next, sum of even terms denoted by q. What is the q value? What is the q value? C1 into x power n minus 1 into a plus C3 into x power n minus 3 into a cube plus 1, like this. So according to data in this expansion, sum of odd terms given by p, sum of even terms given by q. That means here, what is the p plus q value? Tell me. If you add these two, you will get this expansion only. So p plus q value is nothing but x plus a whole power n, you will get. If I did p minus q, if I did p minus q, tell me what is the p minus q value? C naught x power n minus C1 into x power n minus 1 into a plus C2 into x power n minus 2 into a square minus C3 into x power n minus 3 into a cube. Like that you will get it now. What is that value p minus q? Nothing but x minus a whole power n. So till here, according to the data, I written here p value, I written here q value, then I cross check what is the p plus q value, what is the p minus q value. So I hope that till here you can understand. Now here I am writing. Now p square minus q square. According to the formula p square minus q square, how I can write? P minus q into p plus q. I can mention like this. But what is the value? First of all, p plus q value. P plus q is equals to x plus a whole power n. This is the value. P minus q value nothing but x minus a whole power n. This is the value. Here also power n is there. Here also power n is there. If you multiply these two values, I can get x square minus a square whole power n. So the first bit is that value only. P square minus q square. This is the first bit. P square minus q square equal to x square minus a square whole power n. Okay, it is over. Next, second example. What about this value will be? 4pq. Simple logic here also. My requirement is 4pq. How I can add 4pq value? Tell me. P plus q whole square plus, sorry, here minus p minus q whole square. Can I mention like this? My requirement is a 4pq. This 4pq value I can write p plus q whole square minus p minus q whole square. But what is the value p plus q value? P plus q value nothing but x plus a whole power n again square 2 power n minus p minus q value. According to here, what is the p minus q value? This is the value. So here I can get x minus a whole power n again whole square you will get. Means the total value x plus a whole power 2n minus x minus a whole power 2n is the value. Okay. So this also JEE mains point of view. This kind of bits also chance is there. This is the one more example for basing on the binomial theorem. Okay. Now in the next class, a few more examples I will explain basing on this binomial theorem, and then later we will go to different kinds of it. Till now, a plus b whole power n. N is the positive integral index we are doing. Further, we will discuss if n is negative integral value, what about the value, all these things. Maybe I hope that tomorrow we will enter into those concepts also. Okay. Thank you.